Hi! A great day, everyone. I am Josel Pihalon, and I am a lecturer of MTG. I hope that you will learn something from this video presentation that you can use in your future competitions or maybe in your classroom. For this video presentation, we will talk about numeral systems and application. In mathematics and digital electronics, a binary number is a number expressed in base 2 numeral system or the binary numeral system, which uses only two symbols, typically 0 and 1. Let us recall the different rules of exponents. First, we are going to assume that x and y are elements of the set of real numbers, and n and m are elements of the set of integers. First rule: the nth power of the product of x and y is simply equal to x raised to n times y raised to n. Second, product rule: if x raised to n is multiplied to x raised to m, it is simply equal to an x raised to n plus m. Since the bases are the same, we simply have to add the two exponents. Similarly, for the quotient rule, if we will have x raised to n over x raised to m, it is simply equal to x raised to n minus m. For division, we simply have to subtract the exponents. Fourth, power rule. Let us say we are going to have x raised to n raised to m. This is simply equal to x raised to n times m. Fifth, any number raised to 0 except 0 is equal to 1. Sixth rule: x raised to a negative n is simply equal to 1 over x raised to n. In this handout, we have 3 sets of problems. First, warm-up practice with 10 problems. Next, we have Power Plus with 10 problems. And last, we have Take the Challenge with 18 problems. Suppose we have a number in base 10 and want to find out how to represent that number in, say, base 2. Write the base 10 number 59 in base 2. Now, as we can see in our solution, given the number 59, we are going to divide it by 2. Note that when we divide 59 by 2, our quotient is 29 with a remainder of 1. Now, the process will continue until such a way we will have a number that is smaller or less than the number 2. Note, 29 divided by 2 is 14, remainder 1. 14 divided by 2 is 7, remainder 0. 3 divided by 2 is 1, remainder 1. Thus, we can write the base 10 number 59 in the form 1, 1, 1, 0, 1, 1. For example number 2, take note that we have two expressions with factors that are the same. So for example number 1, we have x times y times x times y times x times x times y times y times y. Note that we can write this one in exponential form. We simply have to count how many x's we have and how many y's we have. Thus, with this, we can say that we can simplify the term in A as x to the power of 4 times y to the power of 5. Similarly, for part B, we can simplify the term by writing b cubed times c cubed minus a raised to 4. Now, we have to recall our definition of exponents. Let us consider the term a raised to n. A is called the base and n is called the exponent. So what does it mean? It means that we are going to multiply a n times by itself. Example number 3. We are tasked to convert the numbers in base 10 to the bases indicated. For part A, 43 is tasked to convert it to a base 3 number. So similar to number 1, we just have to divide 43 by 3 and we will have a quotient of 14 and a remainder of 1. And the process will continue. 14 divided by 3, we will have 4, remainder 2. Then 4 divided by 3, we will have a quotient of 1, remainder 1. Now, we are going to read the new number from the last remainder to the first. Thus, 43 in base 3 is equal to 1121. Similarly, the number 678, when converted to a base 5 number, is written as 12203 base 5. For part C, if we are going to convert the number 835 to base 7, we will just divide this number by 7 until we will have the last remainder. Thus, we will have 2302 base 7. For item number 4, we are tasked to convert the following numbers bases to the base 10 system. So in other words, we are going to have the other way around or the reverse of what we have done earlier. For part A, we have 1201 base 3. We are going to convert it into a base 10 number. Now, we will have to recall that the 1 at the thousands place is raised to the power of 3. The 2 at the hundreds place is raised to the power of 2, and so on. So in this case, 1201 base 3 is simply equal to 27 plus 18 plus 0 plus 1. When simplified, we have this as 46. Now, the same idea will be applied for part B. We have 4321 base 5. We can write this as 4 times 5 to the third power plus 3 times 5 to the second power plus 2 times 5 raised to 1 plus 1 times 5 raised to 0. So this is simply 500 plus 75 plus 10 plus 1, and simply equal to 586. For part C, we have 2345 base 7, and this can be written as 2 times 7 to the third power plus 3 times 7 to the second power plus 4 times 7 raised to 1 plus 5 times 7 raised to 0. When simplified, this is equal to 866. We are going to proceed to example number 6. Given R represents the base number in A, for R greater than or equal to 10, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15, and so on. So for part A, we are tasked to convert 8AB base 16 to base 8. Well, if you will think about it, the given is in base 16 and we are tasked to convert it into base 10. So we simply have to convert the base 16 number to base 10 first. Then from base 10, we are going to convert it to base 8. Thus, 8AB base 16 is equal to 8 times 16 to the second power plus 10 times 16 to the first power plus 11 times 16 raised to 0. When simplified, this is equal to 2,219. Next, since that given number is already in base 10, we simply have to convert it into a base 8 number. Thus, we will do the same thing as what we have done previously. We will keep on dividing the given number by 8 until such a way we will have a number or a quotient smaller than the number 8. Thus, we will have 2,219 divided by 8. This will give us 277 remainder 3. 277 divided by 8, we will have 34 remainder 5. Then 34 divided by 8, we will have 4 remainder 2. Thus, we say that 2,219 is equal to 4253 base 8. Thus, 8ab base 16 is simply equal to 4253 base 8. Now, the same idea will be applied for part B. We simply have to convert it first to base 10. Thus, 1232 base 5 is equal to 1 times 5 to the third power plus 2 times 5 to the second power plus 3 times 5 to the first power plus 2 times 5 raised to 0. And this is equal to 192. That 192, remember, it's base 10. So now we will have 192 divided by 16. We will have this one to be equal to 12 remainder 0. But 12 is C. Thus, we can say that the number 1232 base 5 is simply C0 base 16. Now, before we continue, a simple reminder for everyone. If ever you feel that the discussion is somehow difficult or maybe you have missed something, well, you can always hit the pause button and try to reread the questions. So there we have it. I think we are now ready and well equipped to answer the different problems that we have on your handout. Now, please refer to your handout. Warm-up practice number 1. We are going to convert the following base 10 numbers into the required base. Number 1, 16 into base 4. This is equal to 100 base 4. Number 2, 16 into base 2. This is equal to 10000 base 2. Number 3, 30 into base 4. This is equal to 132 base 4. Number 4, 49 into base 2. This is equal to 11000 base 2. Number 5, 30 into base 3. This is equal to 1010 base 3. Number 6, 44 into base 3. This is equal to 1122 base 3. Number 7, 133 into base 5. This is 1013 base 5. Number 8, 100 into base 8. This is 144 base 8. Number 9, 33 into base 2. This is equal to 10001 base 2. Number 10, 19 into base 2. This is equal to 10011 base 2. Part B, number 1. Simplify the following. Leave the answer in index form. So for part A, we will have y raised to 6 times y raised to 2. If we are going to recall about the different rules, this part A will simply be the application of product rule. We simply have to add the exponents. Thus, part A is equal to y raised to 8. For part B, we have y raised to 6 raised to 2. This is an application of the power rule. So, this is the same as y raised to 6 times 2, or simply y raised to 12. For part C, we have b raised to 9 divided by b. Well, you have to recall that if we only have the factor b, it's considered that it is raised to 1. Thus, an application of the quotient rule. Therefore, this is b raised to 9 minus 1, simply b raised to 8. For part D, this is the application of the first rule that we talked about a while ago. So this is the third power of 2 times y. So this is simply 2 raised to 3, then times y raised to 3, or simply 2 cubed times y cubed. Similarly, for part E, we have the cube of r over 4. So this is simply r cubed over 4 cubed. Without using calculators, find the value of the following. A. The cube of negative 9. This means negative 9 times negative 9 times negative 9. This is equal to negative 729. Part B. The fourth power of 11. This is equal to 11 times 11 times 11 times 11. Now when we simplify this one, this is 14,641. Part C. 2 cubed minus 8 squared. So we have to expand first the 2 cube. This will give us 2 times 2 times 2 minus 8 times 8. So when simplified, this is equal to negative 56. Part D, we will have 3 raised to 4 plus the square of negative 7. So this is 3 times 3 times 3 times 3 plus negative 7 times negative 7. When simplified, we will have 81 plus 49, so this is equal to 130. For item number 3, we are asked to write down the place value of the underlined digit in each of the following. For items like this, we need to consider two things. First, determine the underlined digit and determine the base. So for item number 3A, we have 18 base 10 with the underlined digit 8. So considering the place value, we will simply have 10 raised to whatever is the position of the underlined digit minus 1. So we will have 10 raised to 0. So meaning this is equal to 1. For part B, we have 271. So in this case, the underlined digit is 7. Thus, we will have 10 raised to, note, 7 is in the second digit from the right. So that's 10 raised to 2 minus 1, or 10 raised to 1. So the place value is 10. Next, part C, we have 1101. The underlined digit is 0, and this is in base 2. So we will have 2 raised to 2 minus 1, or 2 raised to 1 equals 2. For part D, we have 10100 base 2, and the underlined digit is 1. Since the underlined digit is in the third place from the right, so we will have 2 raised to 3 minus 1, or that is equal to 2 raised to 2, and that is equal to 4. For part E, we have 1B69 base 16. The underlined digit or letter is B. So B is the third number from the right. So we will have here 16 raised to 3 minus 1, or 16 raised to 2. When simplified, this is equal to 256. For part F, we have 27D base 16. The underlined digit is 7. So we will have 16 raised to 2 minus 1. So we have 16 raised to 1 equals 16. For item number 4, we just need to write the following numbers in its expanded form. So for part A, we have 758. So this is equal to 7 times 10 raised to 2 plus 5 times 10 raised to 1 plus 8 times 10 raised to 0. For part B, we have 714. So this is equal to 7 times 10 raised to 2 plus 1 times 10 raised to 1 plus 4 times 10 raised to 0. For part C, we will have 1011 base 2. So this is equal to 1 times 2 raised to 3 plus 0 times 2 raised to 2 plus 1 times 2 raised to 1 plus 1 times 2 raised to 0. For part D, we have A712 base 16. We have to recall our previous example since we have the letter A, so A will represent 10. In this case, we will have 10 times 16 raised to 3 plus 7 times 16 raised to 2 plus 1 times 16 raised to 1, then plus 2 times 16 raised to 0. For part E, we have 53EF. Now we have to recall from our previous example, the letters E and F will represent 14 and 15 respectively. So this given will be equal to 5 times 16 raised to 3 plus 3 times 16 raised to 2 plus 14 times 16 raised to 1 plus 15 times 16 raised to 0. For part F, we will have 1010111 base 2. This will give us 1 times 2 raised to 6 plus 0 times 2 raised to 5 plus 1 times 2 raised to 4 plus 0 times 2 raised to 3 plus 1 times 2 raised to 2 plus 1 times 2 raised to 1 plus 1 times 2 raised to 0. For item number 5, we are going to represent each of the following number in denary numeral. So when we say denary, it's just base 10, the usual number that we use. So for part A, we have 2 times 10 raised to 2 plus 9 times 10 raised to 7. So when simplified, this is 297. For part B, we have 5 times 10 raised to 4 plus 2 times 10 raised to 3 plus 3 times 10 raised to 2 plus 2 times 10 then plus 5. So when we simplify this one, this is just equal to 52,325. Let us proceed to the different items that we have on Power Plus. Number 1. Find the value of the following. Part A, we have the negative of 7 raised to 3. So this is equal to a negative of 7 times 7 times 7. So the result will give us a negative 343. Part B, we will have the cube of negative 7. So we will have here negative 11 times negative 11 times negative 11. And this will give us a negative 1,056. 331. For part C, we have the square of negative 2 minus 2 squared plus 3 cubed plus 7 raised to 3. When simplified, this is equal to negative 2 times negative 2 minus 2 times 2 plus 3 times 3 times 3 plus 7 times 7 times 7. If we are going to simplify this, we will have 4 minus 4 plus 27 plus 343. And this will give us a total of 370. For part D, we have 4 squared times the cube of negative 6 times the square of 7. When simplified, we will have 4 times 4 times the quantity negative 6 times the quantity negative 6 times 7 times 7. If we will simplify this one, we will have negative 169,344. Item number 2. We are tasked to simplify the following expressions. For part A, we have k times 2k times 3k. So this is just an application of the product rule. We simply have to multiply 2 and 3 to get 6. Then for the expression k, we will have to add the exponents. So we will have k raised to 1 plus 1 plus 1. So when simplified, we will have part A to be equal to 6k cubed. Part B, we have 3x times 4x times 1/2 x times x. Again, this is just an application of the product rule. So we simply have to add the exponents of the expression with base x. So when simplified, we will have 6 times x raised to 4. Part C, we have 4y times 4y raised to 4. So again, we just have to add the exponent as an application of the product rule. Thus, we can simplify this item for part C as 16 times y raised to 5. Part D, we have negative p cubed times negative 6p. So when we simplify this expression, similar to the previous items from part A to part C, we will have here the product to be equal to 6 times p raised to 4. We will skip items from 3 to 8 because I believe that you can answer these items on your own. These items are just similar to the previous items that we have discussed. Now, let us proceed to item number 9. For this item, the scores of Leo and Danny are presented using paper clips. A paper clip that is upward represents 0, and a paper clip that is downwards represents 1. So for part A, we need to figure out the scores of Leo and Danny. For the score of Leo, reading the position of the paper clips, we will have 1 0 1 0 1 0. If we will try to write this one in terms of the denary system, we can have this to be equal to 42. While Danny's mark is 1 0 0 1 1 0 base 2. So we can also write this one as 39 base 10 in the denary system. Thus, with this, we can say that Leo has a higher mark than Danny. Then for part B, we are tasked to determine who got a lower mark. Well, consequently from part A, since Leo got 42 and Danny got 39 only, so Danny had a lower mark. Now, for part C, what is twice the difference of their marks? So when we say twice the difference, This is just equal to 2 times the quantity 42 minus 39. When simplified, it is equal to 6. For the items under Take the Challenge, we will only discuss the odd-numbered problems, while the even numbers will be left for your practice. Item number 1. We are tasked to simplify the following expressions. Well, as you recall, we already have done something like this in the warm-up practice. So we just have to recall the different laws of exponents. Part A, we have a raised to 3 times a raised to 6 times a raised to 11. Applying product rule, we simply have to add all the exponents. So we will have a raised to 3 plus 6 plus 11. When simplified, we will have a raised to 20. Part B, we have the cube of 2 times x raised to 3. So this is an application of the power rule. We will have here 8 times x raised to 9. For part C, again, application of the power rule and also application of the product rule, we will have the square of ab squared c squared times a squared bc. This will be equal to a raised to 2 plus 2 times b raised to 4 plus 1 times c raised to 4 plus 1. If we will simplify this expression, we will have a raised to 4 times b raised to 5 times c raised to 5. For part D, we have the expression negative y cubed z times x cubed y times negative x squared z cubed. If we will simplify this, we will have negative 1 times negative 1 times x raised to 3 plus 2 times y raised to 3 plus 1 times z raised to 1 plus 3. When we simplify this, we will have x to the power of 5 times y to the power of 4 times z to the power of 4. For item number 3, using the digits 0, 1, 7, and 9 only once, we are going to determine the difference of the largest and the smallest number that we can make. So the largest number that we can write here is 9,710, while the smallest is 1,079. Thus, if we subtract the two numbers, 9,710 minus 1,079, we will have the difference 8,631. Item number 5. For this item, we have two questions. For part A, we are tasked to determine all the 5-digit binary numbers that when converted to base 10 number, we will have it to be divisible by 3. So, we will have the following numbers that will satisfy the condition. We will have 10010 base 2. In base 10, this is 18. Next, we have 10101 base 2. In base 10, this is 21. Next, we have 11000 base 2. In base 10, this is 24. Next, we have 11011 base 2. In base 10, this is 27. Then last is we have 11110 base 2. In base 10, this is 30. Part B, we simply have to add all of these 5 numbers and represent it into a binary number. So we will have 18 plus 21 plus 24 plus 27 plus 30. When simplified, this is equal to 120. that's in base 10. Now, since our goal is to write this one into a binary number, so we keep on dividing 120 by 2. So we will have 120 divided by 2, that's 60 remainder 0. Then 60 divided by 2, that's 30 remainder 0. Now the process will continue until such a way we are going to have 1. Thus, 120 in base 2 is 1, 1, 1, 1, 0, 0, 0. For item number 7, we are tasked to convert the base 2 number 1011100 into hexadecimal. So what do we mean by this hexadecimal number? When we say hexadecimal, it's just a number with base 16. So with this, the idea here is we simply have to convert first the base 2 number into a base 10 number. Then from base 10, we are going to convert into base 16. So we will have here the given 1011100 base 2 to be equal to 92. That's in base 10. Then from 92, we are going to convert it to base 16. So we will have 92 divided by 16. We will have 5 remainder 12. Now we cannot write 12 in a single place value, so we are going to write it as C. So therefore 92 base 10 is equal to 5C base 16. We have 3 parts for item number 9. For part A, we are tasked to determine the total number of flats in estate A by using index notation. So we can have here 5 times 5 times 5, and this is equal to 5 to the power of 3. Second part, we have the total number of residents in estate A by using index notation. So we can present this one as 5 times 5 times 5 times 5, and this is equal to 5 raised to 4. When simplified, this is 625. For part B, the total number of flats in estate B using index notation will be equal to 15 times 15 times 15, or this is 15 raised to 3, and when simplified is equal to 3,375. Now for part C, Leo is claiming that 15 raised to 3 is equal to 3 times 5 raised to 3. Well, if you will think about it, these values are not the same. So we should not agree with the equation that Leo was proposing, because 15 raised to 3 is equal to 3,375. Where in fact, we can write the 15 raised to 3 as the cube of 3 times 5. So therefore, the equation that he wrote is not correct. For item number 11, we have a base 10 number that can be expressed as ABC base 7 and also as CBA base 5, and we are tasked to determine this number. So with the given condition, note that we can write ABC base 7 to be equal to CBA base 5. From this condition, we can write that 49A plus 7B plus C is equal to 25C plus 5B plus A. When simplified, we will have 48A plus 2B is equal to 24C. Now clearly, C must be less than or equal to 4 and at the same time greater than or equal to 2. With these conditions, we can say that C is equal to 2, B is equal to 0, and A is equal to 1. Thus, 102 base 7 is equal to 201 base 5. Now we can use either of these two to determine the base 10 number. So let us say we use the base 7. Thus, we will have 1 times 7 raised to 2 plus 2 times 7 raised to 0. When simplified, we will have 49 plus 2 equals 51. For item number 13, this is just similar to the process that we have done for item number 11. The conditions are the following. Mr. Russell is MN years old and his age is NMM in base 4. So how old is he? So for this, we will have MN is equal to NMM base 4. So when expanded, we will have 10M plus N is equal to 16N plus 4M plus M. So we will have 5M equals 15N. So M is equal to 3N. Thus, we say that M is equal to 3 and N is equal to 1. Therefore, Mr. Russell is 31 years old. For item number 15, we are tasked to find the value of 345 base N if 140 base N is 4 times as big as 23 base N. So from these conditions, we can write 140 base N is equal to 4 times the quantity 23 base N. So when we expand this expression, we will have 1 times N raised to 2 plus 4 times N plus 0 times N raised to 0 is equal to 4 times the quantity 2 times N raised to 1 plus 3 times N raised to 0. If we will simplify this one further, we will have N squared minus 4N minus 12 is equal to 0. So by factoring, we will have the quantity N minus 6 times the quantity N plus 2 to be equal to 0. With this, we will have two possible values for N. We will have negative 2 and 6. However, the negative value will not work for this case because we will only consider the positive numbers. Thus, we consider N to be 6. Therefore, we will have 3, 4, 5 base 6. N is equal to 6. This will be equal to 3 times 6 raised to 2 plus 4 times 6 raised to 1 plus 5 times 6 raised to 0. When we simplify this, we will have 137 base 10 or simply 137. For number 17, we are tasked to determine the number of different types of packing can a customer buy each time. So with this, we have to consider that 1 can be written as 1 base 2, 2 is 10 base 2, 4 is 100 base 2, 8 is 1000 base 2, 16 is 10000 base 2. So we simply have to add all of this. Thus, we will have 1 plus 10 plus 100 plus 1000 plus 10000. And when simplified, this is the same as 11111 base 2. So if we simplify this, we will have 16 plus 8 plus 4 plus 2 plus 1. Therefore, there will be 31 types. And that is our last item for this handout. I hope that you have understood all the items that we have on this paper and that you have learned something. That's all. Thank you for watching. See you next time.